Hey guys, we're going to look at day 6 notes today on geometric sequences. So first, let's look at these first 4 problems, and it says, what is the pattern? So if we're looking at part A here, it says 99, 91, 83, dot, dot, dot. So if we continue the pattern here, well, what is the pattern? Okay, well, we're seeing that each time these numbers are getting smaller and smaller. Well, what are they getting smaller and smaller by each time? Are they getting smaller by 8 each time? Well, 99 minus 91 is 8. 91 minus 83 is 8. So we're noticing that the pattern here is that we are subtracting 8 every single time. Well, what about on B? What are we doing from here to here and here to here? Are we adding or subtracting the same thing every time? Well, it looks like here we're adding 50, and here we're also adding 50. So the pattern here would be add 50. So these two examples, A and B, are like what we talked about before when we talked about arithmetic sequences, where we have a common difference, which are these patterns that we just noted, where it says that we are adding or subtracting the same thing every single time. But what about the pattern on C and D? Are we still adding or subtracting this time? Well, let's look at C. From 3 to 12, okay, and then 12 to 48. Are we adding the same thing now? No, but are we multiplying by something? Well, 3 times what is 12? Times 4. Well, is 12 times 4 48? Sure. So this time, we're actually going to multiply by that 4. Okay, that's our pattern. For D, I go 100, then 50, and then 25. Well, what's the pattern? Well, hopefully we can look at this and say, obviously they're decreasing, they're getting smaller and smaller, and in fact, they're actually getting smaller by half of the value every time. Now, I don't want to say that I'm cutting this, like that I'm dividing by 2, because we always want to say what we're multiplying by. So this would be multiplied by 1/2 every single time. Okay, multiplying by 1/2 is the same thing as saying divided by 2. Okay, if you need to make note of it, this is meaning divide by 2. It's just how we write it with a multiplication problem. Okay, so let's talk about this geometric sequence, because the arithmetic was when we added or subtracted like A and B. But geometric sequence is going to be like C and D, where we're not adding or subtracting anymore. Now we're actually multiplying. So a geometric sequence is a sequence of numbers with a common ratio. Okay, that common ratio is going to be noted by an R value, okay, and it means that we multiply by the same number each time. So that common ratio, that R, is a multiple. It's a number that we multiply by every single time to get to the next piece. Okay, so underneath that we say, okay, is this one geometric or not? Okay, so in order for it to be geometric, we have to multiply by the same number to get to the next number. So what can I multiply 4 by to get to 8? 2. Does that hold true to get to 16? And then to get to 32 and 64. So is this sequence geometric? Yes. Okay, and our common pattern would be our R value of 2. That means we're going to multiply by 2. The R tells us that we multiply. Okay, well, what about number 2 here, where it says 2, 4, 6, 8, 10, 12? If I multiply 2 by 2, I do get 4. But if I multiply 4 by 2, I don't get 6. I actually get 8. So is this being multiplied by the same thing every single time? No, it's not. So it's not geometric. Okay? So the pattern actually here would be arithmetic, where we're adding the same number every single time. In fact, we would be adding 2. Okay? This pattern that we're talking about, that we're looking for, is called the common ratio. And as I said before, it's denoted by the letter R. All right? So we have geometric sequences that can be written as an explicit or recursive formula, similar to what we did for arithmetic sequences. Okay? In these formulas, we're going to have an A sub 1, an R, and an N. A sub 1, just like before, is going to be the first term. R is going to be the common ratio that we just talked about. And N is going to be the term that we are looking for. Term we are looking for. Okay, so here you're going to see the explicit formula and the recursive formula. And all we're going to do is plug in the pieces that we need. So first, let's look at this following sequence. So using the following sequence, 6, 24, 96, 384, first, part A says identify the following. Okay, so let's identify the first term. Well, the first term is 6. Then let's identify our common ratio. So how do we go from one number to the next number? And it has to be what we're multiplying by in order to be calling it an R. So what are we going to multiply 6 by to get to 24? Okay. If you're not sure, remember back from day 1 lesson, we said that we could always take the second number and divide by the first number. So if you're not sure what to do, take your second number and divide it by your first number. You're going to see here that this is a 4. Okay, well, check it. Okay, if you want to use your calculator and check it, you can say, well, does that hold true for the next one that says 24? 24 times 4, it is 96. So I know that I'm getting to the next number. If I multiply that by 4, I am getting 384. Okay, so let's use that to help us write our explicit. So I'm not going to fill anything in for N because this problem didn't tell me a term that I'm looking for. So right now we're just not going to put anything here because I'm not told anything. So my explicit formula, we're going back to here and we're going to write in A sub N and we're going to fill in what A sub 1 is. Okay, I always put my R in a set of parentheses. Okay, so here it's a 4, and we're going to raise it to the n minus 1 power. That should look like an exponential function like we've been talking about. There is nothing to do to this, so leave it. Okay, do not multiply the 6 and 4. Because that 4 is being raised to a power before it can be multiplied by to that 6. Okay? Now let's go and look at the recursive. So the recursive says we're going to state what the first term is. So A sub 1 is 6. Then the second part of that, the only piece that we fill in is the R. So A sub n equals A sub n minus 1. Remember that that just means the term before, the previous term. Okay, and then my R, again, I always go ahead and put that in a set of parentheses so I know that that's being multiplied. Okay, you don't have to. You can use the little multiplication dot if you'd like to. All right, so let's look at number 4. We've got another sequence. It says 2, 6, 18, 54, 162, dot, dot, dot. First, I want to know, is it arithmetic or is it geometric? So ask yourself, the pattern that I'm seeing from one term to the next term, is it adding the same thing every time? Is it subtracting the same thing every time? Because if so, that would be arithmetic. If it's multiplying by the same thing every time, then it's going to be geometric. Okay, so do your little trick. Take the second term, divide it by the first. We're going to get 3. If I do that for the next term, the third term over the second term, is that still 3? Sure. So I'm seeing that there is a pattern, so this one is geometric. Okay, so what is that common difference or common ratio? We said it was geometric, so it's a common ratio, and we just found out that it was 3. So the explicit rule says a sub n equals the first term. Here, the first term is 2 times my r value, which is 3, raised to the n minus 1 power. Okay, that's all. You don't need to do anything. There is nothing to simplify on this one. Okay, so you just leave it as it is. Okay, let's go and look at number 5. All right, number 5 says the sequence, given the sequence 108, 36, 12, 4, write the explicit rule, write the recursive rule, and then find a sub 53. So this one you're going to see that there's an additional question after the 2 rules that we're going to write. So let's write the first rule. Okay? In order to write our rules, we need 2 pieces of information. We need the first term, and we need our common ratio. So what is our first term? 108. What is our common ratio? Now on this one, it might not be as easy, so let's go back to that rule where we take the second number and we divide it by the first number. So I need to do 36 divided by 108. Grab your calculator and do it. 36 divided by 108, and you're going to get 0.33333. Now, I don't want to write that because if you write it, you're going to round it to one of those decimals, and that's going to change it. So the best form here is going to be to make it a fraction. So hit the button above the enter key to make it that fraction. I want the exact number. I don't want a rounded number. So my common ratio here is 1/3. So when we fill in our rule, a sub n equals the first term, 108, times 1/3 raised to the n minus 1 power. Okay? What does this value look like that we've talked about before? Is that similar to our b value that tells us growth or decay? If this is telling us growth or decay, it's between 0 and 1, so that means I should be representing something that's decaying. Well, are these numbers decreasing the further we go? Then that should make sense that this number that's highlighted green should be between 0 and 1. Okay? So let's go on and look at the recursive rule here. So the recursive rule says state your first term. So a sub 1 equals 108. And then we're going to say that a sub n is going to be the previous term, so a sub n minus 1, times my common ratio. That just means I multiply the previous number by 1/3 to get to the next number. Okay. Part C is the different part. Okay? Because now I say find a sub 53. Well, if you remember from arithmetic sequences, that looks a lot like a sub n. So that means 53 is now going to become our n value. So we're going to go back to the explicit, just like we did with arithmetic, and we're going to plug it in. So a sub 53, the 53rd term, is going to be 108 times 1/3 raised to the 53 minus 1. All right, so I'm going to go ahead and I'm going to punch that into my calculator. 108, sorry, type that in wrong, 108, parenthesis, fraction, 1/3, close that parenthesis, raise it to the 53 minus 1 power. All that should be in the exponent, and we're going to get a number. Now this is a very, very small number. So for this purposes, let's just leave it as what we have here. So 1.6715 times 10 to the negative 23rd. 1.6715 times 10 to the negative 23rd. It's a very, very small number. Okay, I'm going to pause this video here because you're going to have to go watch a second video.